conference is about being future-proof. So everything we will discuss today and tomorrow is supposed to be somehow related to that very important aspect. So in today's panel, we will focus on technology. Later during the day, we will have topics around other aspects of being future-proof, like organizational things, cultural things, and those other very important aspects of being future-proof. But in this panel, we will talk about what kind of thinking, what kind of models can we apply to build future-proof technology platforms. So please, for the beginning, let me introduce my guests today. I will start with the people we have here in the room. So Michael Feathers, thank you for joining us. Michael is a chief architect at a company called Globant. That's his current role. He also wrote a book called Working Effectively with Legacy Code. I think it came out in 2004. Yeah. So when I first heard about this book, I assumed it's something to do with COBOL, PL1, and those very nice things, but it's not. So later, Michael will tell us a bit about why is this important and how is it related to being future-proof. And believe me, it is very much on the topic that we have here. Next in the room, we have Professor Philipp Brune. He's a researcher at 2 universities in Germany in several fields of technology, I would say, and business. First of all, he deals with artificial intelligence and NLP, but also has another very interesting specialty related to mainframe computing. So this is something that we will, I'm sure, spend some minutes talking about today and see and hear very interesting points. We also have Mr. Edmond Pajk, one of our dearest and longest customers in Kroz. Mr. Pajk is a CIO of a Slovenian Pension and Disability Insurance Institute. That's the translation in English. I hope I got it right. Mr. Pajk leads a team of great technologists who've been taking care of SPIZ technology platform for many years, and I'm sure he will have interesting things to tell us about how the technology is behaving at the moment, what kind of challenges they had in these last 2 years, and how do they think about the future that is ahead of them. Also, remotely, we have my dear friend and colleague, Michael Heiss. Michael, hello.
Hi.
So I have been collaborating with Michael for 2 years very intensively. We've known about each other for many years more, but actually started collaborating 2 years ago. And it's been very fun and interesting collaboration in everything we did together. Michael currently works as a change agent and a coach in topics related to digital transformation, enterprise architecture, cloud native computing, cultural transformations, and all these interesting things that you are probably thinking about in your daily life. So Michael will also take part in this conversation and share his interesting insights. Okay, so gentlemen, thank you very much for accepting the invitation and being here with us today. So as I said, the main topic of this panel is about how do we build future-proof technology platforms. While I was preparing for this panel session, I went and checked in the Oxford Dictionary what's the definition of being future-proof. And it says that's something which is unlikely to become obsolete. And I found this definition very, very interesting, kind of surprised me. Felt that way, but never actually read the exact definition. So as we all know, these last 2 years have been very challenging for many of us in different aspects. For some of the companies, those 2 years proved that their technology is really resilient, and it helped them switch business models into being more digital, help them serve their clients in the right way, even during lockdowns and these special occasions that we had. For other companies, the technology turned out to be a problem because it turned out to be a constraint which prevented them from being flexible. So I'm interested to hear about your experiences. How did you go through these 2 days? Some of you are owning your own technology platforms. Some of you are consultants working in the field and collaborating with different companies. So I'm sure you have some interesting stories to tell us. For the beginning, Mr. Pajk, can you maybe share about how were these 2 years in SPIS related to the technology platform? How did it behave? What have you learned from these 2 years?
Yeah, Krešimir, thank you. Thank you for the question. Thank you for the invitation. We at Pension Disability Insurance Fund or started, let's say, I believe that the years before, actually before the crisis, before the new requirements determine how well can you face such type of crisis. So we managed to renovate our ICT 10 years, actually. We started more than 10 years before. So we, before the COVID crisis, digitally transformed our institute so that all our business processes were really entirely digitalized. So integrated our customers efficiently with our processes with many digital channels. So that when the COVID crisis came, actually we could react immediately. I believe that it would be entirely different situations several years ago. So then we just basically had to prepare organization to purchase and prepare hundreds of laptops to extend VPN, and actually we could place until the end of the March 2020, we had more than 80% of our staff working remotely, so from the home. But not just connecting to the environment, but really participating in digital processes that we just extended to their homes. So because of this, our productivity improved in these years, in these months when we had let's say 80% of staff of clerks working remotely, we had 10 or 20% higher productivity because it is well-known fact actually. So yeah, I believe that agility and flexibility are most important issues in being future-proof, because we don't know the future requirements. We just need to have the ability to adapt.
Thank you, Edmond. While the technology is here, I will use the opportunity and ask Heiss about his experiences. So, Michal, what have you seen in the market in your collaboration with other clients and other companies? What kind of failure patterns, if you will, have you seen, if any? I don't know. Tell us a bit about that.
So first of all, tech will always be doomed to fail because it's a code-based representation of assumptions of people. And that means tech will always need someone around to fix those wrong assumptions, right? So that's, I guess, why we call it social technical systems nowadays. So we should get used to fixing problems on a daily basis instead of complaining about it. And that brings me to my first failure pattern is it's like not having a dedicated platform team or platform teams that are passionate and responsible for maintenance, resilience, stability, security of the platform, and so on. So it happens quite often that the technology platform is based on the foundation of one or two IT heroes. And well, in this case, at least it's easy to tell who's to blame in case of outages. Another common failure pattern I experienced was the inability to deal with vendor traps, because software vendors will do crazy things as soon as they lose market share or don't gain enough profit from their customers. So if you invest in vendor software, then you're always investing into the social and cultural system. So a future-proof and a sustainable platform should use components and tools that are backed by a passionate and large enough community. And of course, it's important to join that community and participate as well. So that were the common problems I noticed during the last 2 years. So dealing with vendors and having or creating passionate platform teams as big problems.
Thank you, Michael. So Philip, Michael, you also work with different companies in your consulting roles and positions. Would you have something to add to the experiences that we heard from Mr. Pajk and Mr. Heiss?
Well, I would like to, I think, add that or confirm that agility and flexibility, I think, are key. We experienced that in our university during the pandemic, where we had to switch to online teaching immediately, more or less, without any ramp-up time, or only a few days. So, and I think that most universities managed that really good. So it was for the first time that we really, let's say, left away our concerns about privacy and data protection and just did something, and it really worked out well. And I think so that's important, that you are flexible and that the people are willing to change something. So that was the experience that we made in the academic world, but also, of course, in the companies. What we see as consultants and also as researchers, in studying this impact of the pandemic, of course, it was a real big boost for digitalization in Germany. So I can only say that without that, many things would never have be reached so fast as it was in the pandemic. So in that sense, it had a positive effect, that it really kind of gave us forced us to digitalize more quickly than we would probably have done it otherwise. And yeah, so that I think, but to reach that, of course, it's really about flexibility, about the openness to new work models. I think it's highly related to remote work and remote interaction, remote teaching, which was completely new, or not completely, but new to a large extent. And I think that was really really important. And also, I would say that this, the kind of this crisis, without the crisis, maybe we wouldn't have started our company in that way, because it grew rather fast, SQ Solutions, since I think that the topic of mainframe modernization, which is was on the agenda before for some years, was slowly rising, but I think in the last 2 years it got really a big boost. Also due to the very public and very it reached the mainstream media, for example, due to these problems in New Jersey with the insurance, with the unemployment insurance and so on. So I think it gave it a big boost, and we acquired the first project. Maybe also not only to that reason, but I think that customers now are willing to invest in that. Is, I think, also maybe an outcome, on not only an outcome of the pandemic, but it might have been supported by the pandemic. So I think companies start to think about building more future-proof, resilient infrastructures now, and this is highly, of course, related to agility and flexibility, and also related to kind of reducing vendor dependence. So I think these are the 2 points.
We had a good discussion last evening about the mainframe aspect of it. I will come back to it in a few minutes. But before we do that, I wanted to ask Mr. Michael Feathers about his opinion. I read yesterday in one of your blogs a very interesting sentence, which says, "What we see today is a consequence of what came before." So, having that sentence in mind, what would you say are the characteristics of future-proof technology? How would you reason about that?
Yeah, it's kind of interesting to talk about future-proof tech. Is this on? Is it on? Okay, yeah, good. I had to get closer. Yeah, so it's kind of interesting to think about future-proof technology, because the thing that is amazing to me is that basically the thing that we want, the resilience that we want, often depends upon having pieces that can kind of go away sometimes, right? You know, it's interesting when I look at the organizations that have had like some of the best success through COVID and some of our more recent, challenges. The interesting thing is that they are organizations who are very used to going and doing new things and developing new processes and developing new software all the time, right? There's this way in which we basically can become very captured by the technology that we use. This happens in mainframe all the time. And it's kind of like when you are working in a particular domain or particular market, if there's very little disruptive change, then essentially the systems you have will become rather brittle. If you basically have lots of disruptive change, you're forced to basically be a bit more adaptive, right? So I think it's not quite as much as saying, hey, let's become more agile. It's kind of like putting your organization into the situation where you must become more agile and you must become much more reactive. And when you have that kind of thing, it's kind of interesting because it does end up reflecting itself in architecture, but also in organization and culture as well, right? It's kind of interesting that you have like 3 different panels here on culture and organization and technology, but I think they really are all very well connected. And they basically lead to this overall resilience that you can have by going and being thoroughly exercised, I think, in a way. So.
Yeah, we thought about this, maybe connecting this into a giant panel with 20 people, but that one would take like 3 hours, I'm sure. So we kind of decided to distribute it. Your position on legacy code was really interesting to me. As I said in the opening, it surprised me. In your definition, and I will paraphrase, so I ask you please to elaborate a bit on that. Legacy code is each piece of code which does not have sufficient amount of tests and documentation. Have I paraphrased it in the right way?
Yeah, you have, and it's kind of funny because there's many different definitions people can have. I think you create a definition for what you want to highlight, in a sense, right? And at the time that I wrote this, it was really part of an observation that when we have automated tests surrounding systems we're working with, we can find out very quickly whether they're working or not, and that enables a great deal of change. We can change things rapidly and know whether we've actually broken things or not, right? More recently, I basically tend to think of legacy code as, in a more traditional way, which is kind of like when you have more turnover of team than you have of code, right? So if you have people coming and going all the time, but you don't have your code like disappearing and reappearing at roughly the same time, then you get up into this situation where you have lots of code that nobody really understands anymore. And then that ends up being a problem for the organization as a whole, right? So I think this is a big issue that we have going forward with a lot of these things, is that the systems that we build at some point become really hard for us to go and understand and deal with because the knowledge is lost. It's dissipated over time.
So in terms of future-proofing our technology platforms, we might be using the latest and greatest of the technology, but if we are not paying enough attention to these aspects, then we are actually already building something which is obsolete by the Oxford Dictionary definition that I said in.
If I just add one thing with this, I think the one problem that we have is that software has too much value. And because it has value, we hold on to it when we actually should be proactively getting rid of code and rewriting it, okay? Because then we're able to go and sort of like, the code that you write is something that you own and you understand. And, if we have a constant regenerative cycle in our organizations, then we basically have a better, basis for sustainability, in my opinion.
Thank you. So switching back to Michael Heiss, I hope technology still works.
Looks like.
One other very important aspect of designing technology platforms today is, of course, infrastructure. Philipp already touched it a bit with referencing mainframe. We'll come back to that very shortly. But Michael, you are working with companies who are on their cloud journeys. Some of them are even mentioning multi-cloud types of strategies. We are currently working on a couple of interesting projects in that area together. What would you say, what is the right way to strategize about this particular topic today? How do we design something which is future-proof and based on cloud or multi-cloud and those kinds of things? What's your take on that?
I think I should stress the role of APIs in the beginning, because APIs became so important in this area. Without APIs, we would not have distributed system and cloud services, right? So it has become the kind of default interaction pattern for socio-technical systems, because if you use them correctly, they help to hide complexity of system internals. APIs are replacing letters, office phones, and fax machines and human-to-human interaction. But technical systems are much less resilient to change than human systems, because technical systems can't adapt to changes on its own. So I think that means that besides API is something to integrate things with each other, the human system must learn to communicate changes on the API level. So that has to be a non-technical skill in the end. And of course, when talking about distributed systems in multi-cloud, we should also talk about event-driven systems. Event-driven architecture can be very cost-efficient and resilient, but it produces additional problems in the end because of its complexity. But still, I think that we will see more asynchronous APIs in the future, and scenarios like sharing real-time business events with your whole ecosystem and things like that, as soon as we learned how to deal with the new complexity it provides. And of course, asynchronous business APIs will bring up new possibilities regarding big data, AI, and machine learning, but that might also take some time to have enough people around that have those skills in our organizations. So it will take some time as well.
Thank you. So Edmond and Philipp, in your professional life, you are somehow connected with the topic of mainframe. As I said, we had a good conversation last night. So Philipp, I wanted to ask you, if I'm starting today to build a new technology platform, and if I'm choosing mainframe to be a cornerstone of its infrastructure, am I being future-proof with this kind of decision, or am I introducing some kind of a constraint, something negative, maybe?
I think it highly depends on what you mean by mainframe. I mean, mainframe is, in the end, it's a paradigm for a vertically scalable shared memory architecture with a lot of CPUs. And I would say that such kind of architectures are inevitable and important for some kind of use cases that require a high communication overhead between concurrent threads and concurrent processes. For example, in transaction processing, if an application has to share state, like for example, state about locks and so on, between many parallel processes, then a shared memory architecture will always be more efficient than a distributed architecture. But so I think there will always be use cases for such kind of architectures. And what IBM is selling with this platform is barely the most highly scalable, vertically scalable platform, which is IBM Z or a Linux One. If you would start today, of course, you would not use ZOS. What many people consider when they or think about when they mean mainframe, in fact, is legacy applications. So it's legacy applications, and it sometimes is the ecosystem, or mostly it's the ecosystem around the people, the organization, the structures they have, the mainframers who form as, let's say, a kind of isolated community within the organization, the usually rather high average age and completely different processes probably than the rest of the people in the IT and so on. So it's a very complex and difficult picture that you have, and when managers refer to it as the mainframe, they usually mean this conglomerate of old languages, poor documentation, aged employee base, and lack of skills, and poorly processes, lack of tests, lack of testability, and so on. And all this is what they call the mainframe. But it's not the mainframe, it's the applications, and you can have, it's basically legacy applications. So in that sense, I would agree to your definition, because I think that the lack of test and documentation is a typical problem of such kind of applications, not only for COBOL or PL1, but also for newer languages like, for example, Java from the 90s or GSP applications, whatever. So there are other kind of legacy code today in companies. And yeah, so I think if you would refer to mainframe in that way, that is it is commonly used that it is a definition for kind of a legacy application base and legacy organization, then of course you would say you have to get rid of this. You would not start again with something like that. But if you refer to mainframe, to what it actually means, the IBM Z hardware platform and the operating systems and all these elaborated technologies, which are cutting edge and in to many respects sometimes better than the x86 platform. If just look at the Java performance, for example, the Java virtual machine, there will be use cases where you need such kind of machines always, I think, and IBM has an enormous, let's say, advantage in that sense that they have a very elaborate, very high-tech platform. The problem is that the people don't use it, or the companies mainly don't use it because they just use it as the mainframe in this, let's say, legacy way with old applications and old organizational surroundings. And I think that is the difference. But so if you would start today, if I would start, or we are a startup, and we started and we built blockchain applications on Linux One. And we think that Linux One is the best platform for it. So yes, this is a future-proof platform. It has a lot of advantages. Probably not using, in many cases, new customers would be using Linux, not ZOS. So it is a high-end Linux server for very high-end IO-driven, high-end Java workloads, for example. In that sense, it's a great platform, and it is, of course, it's not only future-proof, but it has many nice features like energy efficiency and scalability and so on. So yes and no. I mean, no to the old way of referring to the mainframe, but yes, of course, to what mainframe today actually is if you look beyond the public perception.
Thank you. Edmond, what's your take on this question of infrastructure, or if you will, also mainframe to some extent? You told me yesterday that being a government agency dealing with pension issues, you have to be there in 100 years also. You told me that today you have processes which are related somehow to the events that happened 100 years ago. So having that in mind, how do you think about building future infrastructure, future solutions, which are future-proof?
Thank you. Yes, pension and disability insurance is quite specific activity. So our insurance cases can last for 100 and more years for a specific case. Of course, then our predecessors never stopped paying pensions even during the Second World War. And so our horizons are a little bit further away. So we are aware that in the crisis, our obligations are even more important to be able to fulfill. So so this is one, let's say, concept that we try to use when speaking about our strategy towards infrastructure or applications or being future-proof. But regarding infrastructure, so our current vision is private cloud, actually, with combining with, of course, some non-core business services that can be in public clouds. But we try to actually to get to reduce risks wherever is possible, to reduce dependencies. This is valid for our code, for our tools that we use to develop software. So we are very strict, and we understand that we have a lot of software that we need to maintain it, that our cycle is really long. So we are not able to, let's say, to introduce each new thing. But on the other hand, our experience with mainframe are different. So we started our innovation on the mainframe, actually on ZOS. We started the new system, but it didn't work actually. So it would work probably if you would scale up a lot. But after we made some benchmark testing towards the Intel servers, we saw that there was no business case to continue this comparison. So then we actually went to the Intel platform, and we currently are in the migration from the VMware environment with thousands of VM machines to the private cloud, and we will see how. So we try to avoid risk wherever we can, but of course we know that this is not future-proof. It's just maybe you can reduce risks, but you can never be future-proof.
Yeah, that's interesting. You have all mentioned different kinds of encapsulation and abstraction strategies. A couple of years ago, we had Sam Newman here, one of the really important authors in our industry, and he said that all that we do actually is just building new layers of abstraction. Michael, I know you have very elaborate position on this. Would you think it still stands since 2000?
Of course, and
when Sam Newman was here.
Oh. This Michael or Michael? Okay. So yes, definitely. So we are building new layers of abstraction, but we at some point increase complexity because of these layers of abstraction as well. So those are kind of trade-offs. And you see, for example, the low-code movement is some kind of the maximum layer of abstraction, because it's a layer of abstraction to make automation tools accessible for non-technical people. And some may argue that this is not real tech that we should use, but still it's an accessibility feature, and it's needed for dirty, cheap, and quick solutions. And there are far more complicated problems. Then it's better to stick to classic software engineering.
Mentioning of low code and no code platforms, you brought us into a different aspect of building future-proof technology platforms, and that's people and skills and languages which they use while producing these great technology components. So how do we strategize about this? I mean, some of you are employers, for example, Edmond and Spies. We obviously today live in a sort of a bubble with this people and skills issue, because there's obviously a shortage of well-educated IT people. So I'm wondering, what will break this bubble in a way? Are these low-code and no-code platforms going to do that, in terms of that they will make engineering jobs easier, or will maybe artificial intelligence somehow play a role in this context? A couple of months ago, I listened to a podcast with Elon Musk, who talked about how in a Tesla car, the ratio between C and C++ code versus neural networks doing functional things, it's actually changing rapidly in favor of neural networks, which means that C and C++ code is rapidly shrinking in a Tesla car, which is, as we all know, a platform. So what will that do to our industry and to our reasoning about building future-proof platforms? Philipp, artificial intelligence is one of your areas. I guess you have a position on this.
Yes, of course. So first of all, I think that AI will help to improve, and already is helping to improve productivity of developers. And also AI could solve problems that in a more intuitive way that you don't require programming for. So like in this Tesla car, it could help. My general experience from the last 20 years or more in software development, however, is that with all these nice tools and improved tools we have, I mean, it's not only AI, we have had improvements in tooling all the time. We had object orientation, we had nice IDEs, code generators, and scaffolding and whatever. So our tools are getting better and better, and our languages are getting better and better since the beginning of IT. The big problem is, during all these years, the amount of people that we lack, for example, in Germany in the IT field, has stayed constant or even has grown, and it is predicted to grow even further due to demographic decline or demographic change. So I doubt that AI or low code or any of these technologies will really solve the skill problem, because it has no improvement that we had before has solved the skill problem. What happens is that the demand and the ideas and the requirements of the customer are growing faster than the tools can increase productivity, always. And it has always been the case. And now we have AI, and now the people say, okay, we have great ideas what we can do with AI. And of course, it increases that is handled by the AI part of the applications. But first of all, there remains another part, and that will not go away. And also, yeah, this just creates new applications, but the old ones are still there, and so the requirements are growing much faster than we can handle them, regardless of the tools we have. So AI is a great tool, and it will have a big impact on rising productivity and solving problems, especially, for example, also in this legacy modernization field, because you can now find more intelligent transformers, you can detect business rules, maybe with AI and so on. But nevertheless, it will not solve all our problems. I mean, IT always has the illusion that there is a silver bullet, and every time, every year, people come and tell you this is the silver bullet, and this let's say simplified approach to say, now if you look at Tesla, C++ is declining, neural networks are increasing, so in the future we will not use coding, we have AI. This is just a very naive thing, and it might be true for some certain domains, like for example intelligent control systems in the cars, but it will definitely not be the case for other applications like business applications. There will be AI in them, but not as much, and because it's not such a simple problem where you have kind of a control cycle that you have to optimize or something. So I don't see that, regardless of the tools we have, we will solve the problem of skills as long as not more people and more young people are interested and willing and recognize that engineering and IT is the future, and that this is the thing to be, and want to learn that, want to study that. As long as most of the young people are studying, becoming teachers or business people or whatever, this will not go away, at least not for Germany, I think, and it probably is the same, similar in many Western countries. So yeah, I think it's a thing that has closely to do with education, and so the only way to get out of the bubble is education and changing the minds of the young people, making making it more popular that these jobs are relevant, that these jobs are kind of giving them the chance to shape the future and so on. So that this is the thing to be. And beside that, I don't see that technology can solve the problem, because technology always improves, but the idea is the demand, and the applications grow faster than the technology.
So Edmond, just like Croatia, Slovenia is also a small country. Do you feel that this, what Philipp just described, does it apply to us also? Are we able to create another generation of well-educated IT professionals which will reduce the problem that this bubble is causing for employers like yourself?
I don't know if we will close the gap, because I think this is not very realistic, but certainly I totally agree on other aspects. So these new technologies will not solve all the problems, as it never does. So AI is currently deep in our systems, so but it has specific tasks where it is good, and we use it in operations, in security, and I don't know, in many fields. But in our business applications, it's almost not present, or it's starting to be more present, and it will be, but it will still be limited. And the similar is probably with other neural networks. Even we don't know what the quantum computing will bring, but usually, as we learned in decades, the new technologies always actually we consume the benefits with the growing complexity of our systems. We actually always have more work to do, and actually the systems are more complex, but we manage to somehow to manage them with additional new technologies, new tools. So I believe we will need the new, of course, developers, our ITs, different staffs for system administrators and other profiles, and we will need to be better prepared to educate them, to include them in the processes. Let's say we really we managed to include the new developer in one day in the so that he's productive, that he has all the necessary tools and the instructions to start to be productive in the development, if he knows, of course, the platform that he's using. So this is the way to go, but I don't think we will close the gap because there is really a lot important shortage of the IT staff, and it will remain so for next decades.
So, Michael, in your next book, which may or may not happen, will there be a chapter about AI solving the legacy code issue with not enough tests, not enough documentation?
Yeah, I haven't really thought too much about that one, exactly where AI would stand in that. It is interesting, though, that, you know, just thinking through this, it seems like we're not going to do anything that's going to close the gap in terms of, you know, we have a smaller number of people working on all these problems. I think the thing that's kind of interesting to recognize about this is that this really pushes us towards the more high value things within the industry. If you don't have enough developers, then essentially what happens is that, you know, wages go up and things along those lines. You have a cost that's incurred by working on low value problems within the industry, right? So there are things, technological improvements like AI and stuff like that, that basically can help us, you know, deal with things that aren't quite as high value and basically go and raise the bar with those things. But for the most part, it does seem that that, you know, we can expect a migration towards higher value problems, you know, going forward, just because this seems to be a durable problem with us. I think the thing with AI that's really kind of fascinating, if you look at things like GitHub Copilot and stuff along those lines, to basically go and help you make sense of code that exists already, and, you know, all these different types of things. It's like, you know, systems will actually try to go and write code for you to go and basically solve a particular problem based upon a narrative problem statement. You know, it's very much like the self-driving car, where basically you do need a human at the wheel also, just in case of the emergency. And I think that there's really nothing in the AI space that goes and prevents us from having to understand what it is that we're actually producing, or at least to be able to go and sort of like say, that's okay and that's not, right? So there's always going to be this human at the wheel at some level of the process that's going to be important for us.
So you are confirming there's a book coming?
I've done that before.
Okay, before we open up for questions, I have one more question for Michael, while the technology is still here. Is it really possible, in your opinion, to build a future-proof technology platforms?
Well, I guess it's possible, but it's hard to do. So at first, I think we need to find a new balance between efficiency and effectiveness in order to create something useful, resilient, sustainable, and future-proof. In the past, I think in the IT, we valued efficiency too much. And during the last 2 years, we noticed in the non-digital ecosystem that lack of resilience is always in favor of efficiency, but it causes problems in the end if there are outages in the value chains. And what we are basically creating at the moment is digital value chains. So we think we need to learn how to map and think about these digital value chains, also regarding the technology we use. So, and this is, I think, a really complicated task, because it's not really transparent how these technologies and services are provided or built. But it will be important, I guess.
Yeah. So it means we are staying at the steering wheel, and no AI will solve our problems. Okay, thank you all. Please, dear audience, if you have any questions, now is the time for this particular topic and this particular panel and our dear guests here.
And I think, you know, to address this, I think when we talk about future proofing, it's kind of like we really have to have organizations that are adaptable and diverse enough, have a diverse technological ecosystem, enough to be able to sort of react and move in the directions that you need to go, regardless of where the future carries us, right? So it's kind of like, I don't think we can really count on the technical systems as much as the processes and people systems that we have in place, and having a wide variety of different technologies that we are capable within an organization, so that we can kind of pounce on the ones that basically are, you know, serving whatever direction we need to go in at the moment. So, yeah.
So maybe to make it a bit more concrete, so the clients and companies which I am working with, typically we talk about enterprise core systems, some kind of legacy or not, but it's enterprise applications, and the usual life cycles of these applications in banking or car industry or other industries is typically many decades. Some of these systems have been evolving over decades, and when we talk now about modernization and making them more flexible and new APIs and more platform independent, whatever, these are large investments, and they are not made on a. First of all, it takes some time, so we are planning about some years, and then, of course, the customers want to have some return on it. So I think the typical period would be 10 years. So you plan a new system or a modernization initiative, typically with the goal to do it over some years, 5 years, 10 years. So future-proof would mean to me that in 10 years you would say, okay, it's still a good architecture, and we can build on that to improve it. And beyond 10 years, it's hard because it's a typical value that well, 10 years in IT means infinity. So it's like you don't know. But in these enterprise systems, you need to have a planning horizon. Let's just imagine a car manufacturer like BMW, for example. They have they think about a new model generation. It's a 4-year cycle, and they're planning the next and the over next generation on working on that. So they have kind of a plan for the next 8 years, and the IT systems, of course, have to follow that as well. So I would say 10 years is a good value for what we would call future-proof, because the companies already think today about what will be in 4 and in 8 years or in 10 years, and that is the typical planning distance.
Any other questions?
I have just one question to Professor Brune. When you say mainframes and we associate that with IBM, then there's just one tree in this forest. It's the IBM tree. And Fujitsu's are moving out in the next 10 years. So how can this one vendor thing be future-proof?
This one might extend over lunch or something.
Is a good answer to that. I mean, first of all, you're right. Fujitsu is discontinuing the development of the S390 processors, but these have not been compatible with the IBM systems since the end of the last century. So these are two different worlds. They're still mainframes, but even Fujitsu has promised that they will continue the support for BS2000 over that point in the future. Not for the mainframe hardware itself, but for the operating system and the applications. So, but these worlds have been separate anyway. So it is a one-vendor world. If you want to have a high-end system like the IBM Linux One, it is a one-vendor world. But I mean, it's the same if you would buy well, a Spark or Spark systems which are declining, or IBM Power, or any hardware that is not let's say manufactured by multiple parties. But you could say the same is NVIDIA future-proof. Shouldn't we do AI on other platforms, because NVIDIA is a monopoly, has a monopoly or whatever. So I would not say that, because the important part is, for me, the important part about future-proof is that you have abstraction. We already mentioned that, abstraction layers, and independency of vendors. And the abstraction layer that we typically use today is Linux, and the things that are built on Linux, like Kubernetes and so on, and containers. So if you use this kind of abstraction layer, which is completely platform independent, and you have platform independent languages like Java or Python or whatever on top, you are not bound to any hardware. So you can use the benefits of the IBM Linux One system, the hardware, performance, security, whatever, as long as you can afford it, as long as it makes sense. And if it doesn't make sense anymore, economically or technically, you could just put it to another hardware. Probably in the future it might be ARM and not x86 anymore. So we will see. But I think the important part is the vendor independence of the software stack. And to my point, and I have a long history in Linux, let's say featuring Linux also in the banking industry. For me, Linux is the first abstraction layer, and then of course you have the open source stacks like Java and all the ecosystem, and of course the open source components in general that help you to make things vendor independent. And even if you buy support and you have enterprise licenses, you still have the chance to get away with another support and other company and shift it to another platform. So if it's platform independent, if it's containerized, if it's running on Kubernetes and so on, in principle, the hardware doesn't matter, and you can choose the hardware according to which hardware fits best your needs. And in that sense, the mainframe is a future-proof platform.
Okay.
May I just add from our experience? Yes, I totally agree. So we made a benchmark. So for the Linux running on Intel and on the mainframe, and we didn't see any benefits. And also, actually, scalability matters, but it has some frameworks. One of them is financial. So if you need to, let's say, to pay several hundred times more for the scale up the, let's say, memory or whatever, then you're not so much scalable as you can be. So when you consider all these issues, then for at least for our case, it was not a question whether to run Linux on mainframe or not. So we decided not to.
Okay, thank you all, my dear guests today, and everybody here in the audience. That was it for this one. We will of course continue with other aspects of being future-proof. Thank you.